All right, so here we are. I'm a little bit surprised too. It takes me about 5 minutes to realize, to go from, wow, I'm really tired, to, I guess we're giving a presentation. So we're going to talk about building a session layer. And, as usual with these types of things, it's good to start at the beginning so you can end at the end. And we need to talk about what a session layer actually is. It all goes back to the 7-layer ISO model, which, was designed by committee some time back and has been more or less replaced with a 4-layer TCP/IP model. But let's go through it anyways because it's important. First layer, physical layer, the actual wire, the air, everything that actually makes up the physical networking. Then you have your data link layer, your Ethernet, your 802.11, your FDDI, that kind of crazy stuff. And then pretty much on layer 3 you just have IP. On layer 4, TCP, UDP, all those. And then we come to the session layer. Pretty much no one uses the session layer. Some people describe TLS and SSL as the session layer. Not really, but it's the closest we have. The layer 6 is the one probably that everyone makes fun of because it's, character encodings and problems that we solved 20 years ago. And if you actually, are discussing the ISO 7-layer model with someone and they're not a fan of it, they're usually going to point at layer 6 as the one that's pretty much useless. And then everything else goes into layer 7, and we've been seeing more and more and more of everything going into layer 7. And that's what we need to, or what I'm trying to reverse here. So if the session layer isn't here anymore, where did it go? It really went everywhere. It's all over the place. You have SSL, SSH, IPsec, all some forms of session layer in their own different ways. The idea that an individual application should be authenticating users, why would you do that? I mean, you have a perfectly good application, and then you add authentication code to it every single time. My typical example is I want to use SSH keys to log into everything. The fact that I can't log into my web server with an SSH key infuriates me. So basically a bunch of stuff got pushed from the session layer into layer 7 because we never got around to implementing it. This was about 20 years ago. Maybe we can change that today. So this causes more code. When every application is writing authentication functions, their own encryption layers, their own stuff to describe what a session is, it's just wasteful. More importantly, it's more buggy code. Most of the security vulnerabilities that really matter, security vulnerabilities in the authentication code and the encryption code, actual problems. Session layer code that shouldn't be in the application in the first place. And while we're getting rid of things from the application, let's go ahead and, we've got application multiplexing in layer 4. What I'm talking about here is port numbers. Your TCP/IP, your TCP and UDP layers are actually doing multiplexing of, they're not just providing a reliable byte stream, but they're telling you which application to talk to on your computer. Why should we have that there? I don't know. So we're going to yoink it and layer 5 it. By the way, the software itself that I'm presenting here is 5'd, short for layer 5, damn it. Currently, don't run it. It's very much a piece of software that is used for demos. A good portion of the development cycle may have happened in my car yesterday. There was quite a lot that's changed even over the last few days, and certainly if you run it on your computer as root, which you need to for the port number, capabilities, etc. But still, you need some level of privilege. A 2-year-old can hack your box. So really, don't run it. I'm not having my wireless card in my computer right now for a very good reason, because when I demo this software, it would get owned. All right. Now, obviously, this isn't going to be here forever, but it's demo. So here's what's going in. Application multiplexing, authentication, encryption. all in the session layer, all out of layer 7, pushing it into layer 5, and we're going to have software to do it. Things that go away. Port knocking. This was an idea that I just loved a long time ago when someone first said, you know what, we should be able to establish authentication by sending random packets at a specifically described sequence of ports, and suddenly you knock on this port and that port and this port, and you hit the right sequence, and suddenly for you a port opens. I thought that was really clever. But you know what's more clever? Doing it right. So we're going to try and do it right here. Host-based firewalls. You know, everyone loves firewalls. So rarely do they actually improve anything, especially when it's on the host. Your applications are just going to punch holes through them anyways. Let's try and actually make it so that if you don't have services you want to expose to the world, you don't expose the services to the world. Vhosts. This was a thing put in web servers a long time ago because we couldn't figure out how to actually multiplex anything on top of anything. And so instead of getting 17 different IP addresses to determine what website your web server shows when you go to the web server, you use this thing where you stick in the host in the header, and now the web server knows what it's supposed to show you, and it shows you something completely different. Now, of course, when DNS breaks, which when Dan Kaminsky's around it seems to do pretty often, this all goes pretty chaotic, and you're hard coding you're hard coding IP addresses into et cetera hosts just to get things to work properly. So would be nice to try and see if we can't get rid of this too. The typical setup on a nice lightweight server these days is you've got a front-end web server that's doing proxying to back-end web servers, and you've got load balancers and all kinds of things that are really doing this type of thing. And then really, they just really want to be a session layer. They really want to be a session layer. So we're going to try and help them. And we're going to try and get rid of authentication as much as possible. Obviously, you can't do everything, but a lot of it, you just don't need it. You can authenticate yourself to a machine, and you can get all your services one central place. I mean, we have PAM. That was a great start, but it doesn't work so well on the network. Port numbers. Yeah. Really, I'm trying to get rid of port numbers. I think they're terrible, and I think they need to go. Yeah. So if TCP and UDP hadn't done them, we'd have had a real session layer. We'd have had it 20 years ago. Instead, here we are, no session layer, port numbers. So kind of a big deal. Just a little small change here. So please quickly, if you're on the same page here, please shout an expletive. Or excuse me, if you're not on the same page, please shout an expletive. There we go. And if you are on the same page, which none of you should be, interesting. Not a whole lot of audience participation from you folks. I was going to say the best thing about DEFCON was having hundreds of people swear at you, but now I guess I get to look like an idiot. Thank you. I appreciate that. If we can have a little bit more shouting of expletives now and again, accusing people of hating freedom, there we go. I'm awkward when it's just when it's just me up here and I haven't slept, so a little shouted expletive really helps break the mood. So let's take this slowly in the order of most surprising to least surprising. No port numbers. Probably the most surprising thing that I'm going to tell you that I'm trying to get rid of today. There's some precedents. Port mapper, a common RPC service. RPC services generally didn't run on the same port twice, so you needed a port mapper to map an RPC service to an actual port. Very similar. It used ports, but it's kind of the same idea. So really, it's doing the same thing DNS does with IP addresses, except it's doing it with ports. Those of you who really love DNS are going to quietly mutter to yourself, well, what about SRV records? And the answer is you don't use them, so why are you telling me about SRV records? Yeah, and there's a reason none of your software uses them, because not every machine runs its own DNS server. The sysadmin doesn't control the DNS most of the time. Someone else controls the DNS most of the time, so it's not really smoothly integrated to expose those services via DNS. It's just not a good mechanism for port numbers. It's a decent mechanism for IP addresses when Dan Kaminsky's not around, but for port numbers, it's just not very good. So here I am talking big, telling you I'm going to get rid of port numbers, and I haven't told you what I'm going to do yet. Well, RFC 1078. It's one probably no one has heard of. Has anyone in the room heard of this RFC before? Thank you. It's a very little known protocol called TCP MUX, and if you can't guess, multiplexing is going to be a theme in this talk that kind of underlies but isn't terribly well exposed because I made these slides when I was way too tired. And it celebrates its 20th birthday in November, which means it's almost as old as I am. It is, in fact, 1 year older. By the way, coming to DEFCON when you can't drink because it's not legal sucks. Yeah, as it turns out, the fix was wait a while. So TCP MUX is actually a very simple protocol. Its entire specification consists of one paragraph. If you read the RFC, you know how they're laid out. They've got a lot of standard sections, and it's less than 2 pages long. Maybe it's 3. I can't remember. Anyways, the actual protocol specification is a paragraph. Help provides a list of service names. That's help, H-E-L-P, all caps, CRLF. Yep. Type of service name, followed by CRLF. Server responds with plus or minus, the characters, followed by an optional message, and yes, CRLF. And then it says simply, the selected protocol starts. Not sure what that means always, but the selected protocol starts, and that gives us a little bit of room to do things that are a little bit not entirely what they envisioned. The RFC is completely silent on what happens after the selected protocol ends. It doesn't make any mention whatsoever. In fact, it just ends the protocol specification right here with the selected protocol starting. So we've taken some liberty with that. That and the idea of services. We added some... The main point that we really need to use this RFC is it provides a very, very sexy port number. Again, I'm getting rid of ports, so if you're going to run an application, you have to run it over TCP, and you have to have some port number, so you might as well choose an arbitrary and sexy one, right? Run the command, and you get, there we are, port number 1. Did anyone pay close attention in their etc. services file and actually ever see this service? I didn't know this was the one that claimed the first port until I got annoyed one day and said, I want to run something on port number 1. What would I have to do? And then I submitted a talk for DEFCON and wrote software a couple days before, and here I am. So since that port number is too good to pass up, we're compliant with the RFC to the letter, all couple hundred of them. And our protocol is extended via services that are built into the daemon we wrote and enable additional features. Contrary to the Microsoft Embrace, Extend, Extinguish approach, this is going to be the Embrace, Make Awesome, and Make Awesomer approach. So our built-ins, as of today, and I'm not joking, as of today, obviously we have help. This is required by the RFC. It lists your service names. We have auth, a demonstration of which looks like this. So you type in auth, all capitals, CRLF, and it gives you back your required response with a perfectly verbose message of success. And then you can enter a username, and you can enter a password, and it tells you you've authenticated. Now, for those of you who are picky, you'll notice that when I demo this, this is the same username and the same password, and if you were to try anything else, it would probably fail, unless I have a bug, in which case it might succeed. So yes, it's hard-coded in at the moment. Host. This one is what we're going to use to get rid of vhosts, and as you can see, here's our service, host, and it asks you which vhost, and you go to vhost. And then it knows your vhost, and it goes on about its day. This one is the one that actually probably matters from a security perspective for most of you. It's the one that actually allows you to make this thing secure so that when you're typing in, usernames and passwords, they're not going in plain text. this is the protocol that does exactly what you think. You type in SSL, it waits for you to start an SSL handshake, you start an SSL handshake, and it presents you a certificate signed by a 512-bit RSA key. Self-signed, by the way, yeah. So, obviously some room for improvement. Multiplex, which does all the really cool things. In fact, when I was first thinking about this software, this service didn't exactly come to mind. It's why it doesn't show up in the description of the talk. You'll notice in the description of the talk I listed several things like, wouldn't it be nice if we could do X, Y, and Z? And I never said, run 17 TCP connections over one actual TCP connection. This one does that. So it basically, you take as many layer 7 pieces of data and you shove them on one layer 4 connection, or one layer 5 connection if you want to get specific now that we bothered to reopen a layer. And so this changes networking a little bit. The traditional model is your application connects to another application. I mean, this is standard. You have your application, it makes a syscall, it tells you what port it wants to connect, it goes off to another computer and says, I want to talk to the application on that port. It's application to application. With this software, your computer connects to another computer, and your applications use that session to communicate very similarly to what happens today. In fact, we're going to use several existing applications, and by existing I mean Netcat. So maybe it's running a couple of shell scripts too. So in general, it looks like this. You've got your actual app, and it connects to your computer's session client, and that connects to the actual session daemon, which connects to the actual service. So the arrow between the session client and 5 is the one that's supposed to be long, and there's supposed to be an internet in between there. I don't have a little cloudy symbol, so I didn't put the internet there. But that's where the internet would go. But as a matter of fact, if you really wanted to, you could put the internet in between any of these. So 5 could act as a load balancer. It could act as whatever you needed. It can be the example that comes to mind since I'm a student at UCSD is, we could have one session server and it would be ucsd.edu, and then everything could go through that, and you could just have one sweet sign-on system, and I would only have to identify myself once. I could get my mail. I could change my grades. Wait, not change my grades. I could, do all the things that I would expect to do as a student. Drop classes, actually, I think, more often than changing grades. So we're going to go ahead and demo it now, and we're going to try and ignore the fact that I don't actually have 4 different computers, and that really my computer is just pretending to be rampantly multi-personality here. And let's see. First off, Book of Mozilla. I don't know if you ever noticed this, but if you type in about Mozilla in Mozilla, it comes up with a different one that they change every now and again. Anyways, so let's pop this thing into presentation mode. That didn't work. Can you see that? Yes? Awesome. So here we have our demo client. It is, in fact, named demo. And our usage is you can pass an S switch or an M switch. The S switch does SSL, and the M switch does multiplexing. The reason we have a demo client instead of me just showing you with Netcat is because, I really tried, but I can't do an SSL handshake in my head. I wish I could, but it's just tricky. The exponential encryption, it tricky to get right. Okay, so starting the daemon, we've got the services running, and we're doing pretty well on time. Too well. I'm going too fast. Oh well. So we're going to use our demo client. Oops. And here it is. Help. And there we are. So as you can see, we have a perfectly RFC compliant, very simple server here. It's offering... Really? Hold on. It's going to be a little bit tricky. Oop. And... Da-da-da-da-da. Is that good? Excellent. All right, so help is listing the following service, the multiplex one that we saw earlier, the SSL service, the auth service, the host service, and a web service. Everyone loves the web, except me. I'm a communist. But we actually don't want the... yeah, I know. We don't want the plain text one because that's just... You know, it's so much more satisfying when you use a useless cryptographic layer that, you know, is blatantly man-in-the-middle attackable because of bad certificates. So we're going to enable SSL, and now we go ahead and the demo client goes to the server. It goes ahead and does the SSL service and does a handshake, and as we can see, the SSL service is no longer available because we've used it. And we're going to go ahead and switch hosts. We're going to go to a host called toys because it contains things like, you know, an echo daemon and a hello daemon, which really aren't used so much anymore. I don't know why, but, you know, everyone used to have an echo daemon running, and then, of course, someone put the character generation daemon and told the echo daemon to go find the character generation daemon, and the box proceeded to DOS itself. Anyways, we have an echo daemon here. But we're going to use the hello one because it's nice and courteous and it says hello, and then there we go. The protocol's over, the selected protocol began, and the selected protocol ended, and our connection is done. Simple, right? I'm done. No. So the idea, though, is that we want our sessions to be just a teeny bit more persistent here. But before I go there, let's show the rest of the auth here. Oh, with SSL. There we go. Man. Okay. So it would be wonderful, you know, if when I'm looking for a service, it's almost always that I'm looking for a shell. Oh. Well, I guess I'm not going to find one, or at least not until I tell it who I am. And now I have a shell. See? It's a shell. There's the shell. Projects. 5. Oop. It helps if you can type. And there's the entire source code for the program. I hope you caught that. Was it a little fast? Better? I think at the moment that this now qualifies as self-hosting, which is a milestone in the development of every source code management system, except this isn't a source code management system. But if it was, it would be self-hosting. You know, we've got a shell that we're now going to exit from. Okay, so now we need to stop getting our things actually where the protocol ends and everything goes to hell. So let's use this multiplexing thing that we're so excited about, or, well, I'm excited about it. You guys are probably sitting there going, wow, he's really tired, isn't he? So now we're, you know, the S switch enables SSL, the M switch enables multiplexing, and here we are. We've got a multiplex connection. We can do our things before. Let's go ahead and get ourselves authenticated. Demo pass. And here we are. We're authenticated. Let's throw ourselves... you know what? Let's throw ourselves into the other vhost. Ugh, can't type. And here we are. We've got our list of services: auth, host, shell, echo, hello, web. So, web. So now, instead of actually starting the selected protocol, the server starts the selected protocol, but this is the client. And the client noticed that the server started a separate protocol and noticed that it got embedded, slipstreamed, if you will, into the existing session that was open. So now the client, our little demo client, has gone and opened a port on localhost that allows us to access this separate service so that any communication that happens on this port in the future can be slipstreamed back through this one connection. Because, you know, Firefox doesn't yet really know how to interact with my software. They're very slow. I mean, I made it yesterday. Anyways, not with the laughing these days. All right. Localhost. And here we are. we have a fun web page because it's the fun host, or the toys host. And here we are. But you know what? Now that I think about it, I don't want a web page with red in it. So let's go back to the main host, which is more of a business-friendly web page. We're going to run this session or run this connection over this port. So now we have 3 different layer 7 connections going. We have the main one that's interacting with the help menu. Notice how we can still use this one. This is still giving us data. And we had the old web connection, which we shot in the face a while back. And now we have this web connection. They're all running over one physical TCP connection. Only one. And we're not, taking layer 2 packets and throwing them in layer 4. We're actually legitimately taking the layer 7 data and putting headers on it. And not headers on each packets, but actually headers within the reliable byte streams, because this software knows nothing about packets and frankly shouldn't know anything about packets. So now we have our web. You know what? Let's get away from the web. So here's our help. What do you think? I'm taking suggestions on what the next service to multiplex over this connection is going to be. Telnet. I've got a shell. Do you want a shell? So here's a shell, and we can connect to it through Telnet, but Telnet sucks, so let's use Netcat instead. And so, wait, we switched out of presentation mode here. Darn it. Here we are. Now you can see it. So Netcat, we're going to the socket that our client opened up for us, and lo and behold, we have ourselves a fully functional shell, as long as you don't want a prompt or anything else that might resemble a shell. Notice the reset commands absolutely do nothing because you're not running on a real terminal, and this is not a terminal emulator. Which, from what I understand, is about as functional as the SSH functionality on the iPhone these days. Yeah, we went there. Yeah. So now let's start an echo server. Oh, what do you mean no such service? Oh. Well, let's go to the one where don't have spaces at the end of your service names. It's not the service you thought it was. Now let's go back to the host that did have the service. Help. There's our echo service. Gotta love the echo service. It's always boring when someone's sitting there typing commands in a computer. I wish there was something that I could do, but it's hard to show you it any other way. I don't have a nice 3D visualization for networking traffic. I'm very sorry. Okay, so here we are, and there we are. And it's spelled curse words. Yeah. So as it turns out, no spell check here. The computer is happily repeating everything back to us, and of course, we still have our shell running over here, perfectly functional. So let me just recap this again, because it's a very subtle point and it's very important. This connection is running on the same connection that this connection is running on. They're both on the same TCP connection. In fact, if we kill this here, these die. Dead. Completely gone. They're not separate. It's all in the same thing. We're reusing our session. We were known to the computer at the same time. We were completely authenticated. And they all went away. So since I'm running faster than I thought I would, let's go ahead and explain exactly how this works from a little bit more of a technical perspective. So I said that it was multiplexing layer 7 connections down onto the layer 5 service. So the way you would think that this would be done is you would add a header in the packet, and it would tell you which application it is, and if you think about it for a moment, you would have realized that you would have just implemented port numbers. Because that's exactly what TCP does. It tags each packet with an actual number that tells you which application it's coming from and which application it's going to. So we're doing something slightly different. We're actually treating TCP properly as an in-order byte stream, and we go ahead and we throw a header in. As soon as multiplex mode is enabled, we throw a header in that says hi, basically. And a header consists of 16 octets, 4 different fields. The first is a version number, because if you don't have a version number, when your protocol changes, everything breaks. The second one is a application ID. You can pretend it's a port number if you really want. The third one is a series of flags, out of which 2 are defined and the rest are reserved. And the last one is a length. And the length dictates when you'll see the next header. So that's how it works. You know in advance, when you put a chunk onto the network, you take it with the header, and then you tell it where to find the next header. And so it's constantly picking up these headers and then taking the next piece of data and then taking that data and throwing it at an application and then looking at the next header and then slurping up however much data it says to slurp up and then taking that one and throwing it at a completely different application or the same application if the same application sent something twice. There's some optimization tricks you can do here that we didn't, but it's very much possible. So let's see. We finished the demos. We bored the audience. We talked about communism. Okay, so what? More about communism? Soviet Russia. Random parting thoughts, because I don't get a chance to stand in front of a bunch of people very often. IPv6 is sweet. You should all use it. We're running it at home. Automatic configuration. You fire the thing up, you grab a tunnel, suddenly all your computers have IPv6. I joke that it's given me back the internet again because I have a public IP address. It's a useless public IP address because no one can contact it, but it's a public IP address nonetheless, and I'm very happy with that because I had public IP addresses way up until 2000, actually way through, all the way down until I moved into college, and then I was in a metropolis and cable modemed. Anyways, other random parting thoughts. Intel provides microcode updates. Most Linux machines don't run them. Almost all Windows machines do. This is the one place where Linux is really just far behind in security. For those of you who are wondering why I'm not talking about anything related to my topic, it's because I'm near the end of the presentation. He should know because he has to actually deal with x86 all day. Poor man. Yeah, he tells himself that every night as he weeps himself to sleep. Firewalls are a poor man's substitute for security, and security shouldn't be an excuse not to do things. The last one are just philosophical points. Anyways, also for those of you with conference CDs, the slides on them are not the same as the slides I've just presented. They're not quite as terribly atrocious as I said, but there will be updates on the DEFCON website and my own website, and you can grab the current copy of the slides if for some reason you want to see the slides that had so much information on it, like demos. This is really an informative slide, and you should take it back to your workplace and share it with your coworkers.
What's your website?
I'm getting there. Just hold on. Would anyone like to accuse me of hitting freedom or ask me a question? This will continue in room 104 later. I'm sorry, can you... Yeah, so the question was, how does it know when to close a session? So the session client manages completely the session with the session server. So the session client can close a session whenever it wants. If you're asking how the individual applications that are multiplexed on top of the TCP stream know when to close, the header has, again, I said the header had 2 flags that were implemented. One is this ID is new, and that symbolizes to the actual session client that it needs to open up a new stream. And so whenever one of those headers came in, that's what caused this thing to spawn off a port here. So you see this where it says listening on port. That was directly because a header was sent to it that said we have a new ID. And for closing, there's a corresponding one that's the delete flag, and it does much the same thing. Yeah. I can't even hear you. I'm very sorry. It identifies itself to a web server, but it's only made to identify itself to a web server. It's not made to identify itself to a telnet server. That needs to happen on a completely different layer. Someone else? I saw a hand back there. Yeah. I'm sorry, can you stand up and scream a little bit louder? Yeah. Is it going to be a nightmare for network monitoring people? So I'm really wondering where you got the impression that things weren't already a nightmare for network monitoring people. I understand the concern, and I gave a talk at. Well, hold on. I understand the concern, and I was actually with you last year. I gave a talk last year about how virtualization is going to ruin the world because your hardware firewalls basically don't work anymore. People have come to similar ideas recently, and the answer is it going to make it worse? Well, yes and no. It's not going to make it substantially worse because it can decode the layer 5 traffic just as easily. It can decode anything else unless you encrypt it. So the question you need to ask yourself is, are you against encryption because you want to be able to monitor your network better? And if the answer is yes, then yes, this is going to make your network a little bit more of a nightmare because it's actually going to make people encrypt most of their stuff. I don't know if that's a trade-off you want to make. You can put as much logging into this thing as you want. What? What was the last bit? Yeah, I get that a lot. You know what? I have another card drive down, so power inverters are great things, and maybe I'll get some more coding done. But at the end of the day, I'm just not convinced that network monitoring actually gives us nearly as much as it thinks it does, because your attackers are very, very rarely being so nice. Yes, a lot of times you get stupid attackers, and that's not going to change. I think there's nothing fundamentally different about this. Yeah.
Where does IPsec fit? Is that one just SSL?
I'm not advocating SSL here. It happened to be the one that I implemented. I actually really dislike SSL. I don't like the CA model. I don't like the certificate model, and I think overall it's a fairly poor protocol. Not to rag on the SSL guys too much, but there's been breaks because of it, and I feel much more comfortable with a model like PGP or SSH or even IPsec to some degree. And there's nothing that would stop you from applying the same cryptographic properties of IPsec into this, and there's nothing that would stop you from running sessions over IPsec. It's a different layer. Would it decrease the necessity for IPsec? Yes. Yeah.
Just as a hopeful thing, we think that if you can use port 80 instead of port 1 for this tool. The things you could tunnel through the firewall would be staggeringly good.
Yeah, and in fact, if you notice, I actually had it running as a user here, so I wasn't using the new capabilities of the kernel, so I wasn't running it under port 1 either. So there's nothing that says you have to run it under port 1. It's just that you can, and it'll actually be RFC compliant for the purpose of the port, which makes me happy. Anyone else? Yeah.
When you multiplex several things over one connection, that means that it all has to be in order. So if you multiplex BitTorrent traffic and video traffic over one in-order connection, one of the BitTorrent traffic packets gets lost, and then play both BitTorrent and the video.
Not even a little bit, because okay, yes, to some extent, because at the end of the day, your client your actual your actual session daemon sees an in-order byte stream. A drop in one packet will cause a drop in the other, which is no different than using TCP elsewhere. The other thing that people run to UDP a lot just to implement low latency things, and I wonder if they've seen the urgent pointer, because there's nothing stopping you from applying it everywhere. Now, you would need to change how the headers are working, and how the multiplexing would have to happen to use this, and you would need to give it a little bit more concept of what a packet is. But there's no reason why you can't use the out-of-band data mechanism to provide a a very low latency response time over TCP. Yeah.
How do you feel this competes with
Not terribly familiar with the protocol, to be honest. How do I feel that it competes with SCTP, which is if I remember right, it's tries to be a replacement for layer 4. Yeah. So by the description that I've seen of it, it's doing things a little bit differently. It's not actually. A lot of things can be compared to this. How do I feel that it compares with a VPN? How do I feel that it compares with Stunnel? And the answer is, well, they're kind of similar, but this one was made with a very specific purpose that so far I haven't seen fulfilled. And it's kind of subtle, and I'm not sure I did a terribly good job of explaining it, but if you'd like to send me an email, I'd be happy to go on and on for pages about it. Yep. Yeah, absolutely nothing at the moment. But the question was, when this happens here and your client says, I'm opening a port to whoever wants to grab it, the question was basically, can someone else grab it than who was supposed to? And the answer is yes, absolutely. But obviously, this solution that we used here in this particular one about opening a port and making it a free-for-all for everyone is not the one that we would want to see eventually. If this were to actually go anywhere, you would want to see it integrated at the low-level syscall level, where it would actually be able to appropriately identify which applications the user intended to use, if that makes any sense. It would need some knowledge to be properly functional, yes. Instead of asking for a port number, you'd ask for right now you go ahead and you give it an IP address and a port number, and the operating system runs off and starts a TCP connection for you. So instead, you give the operating system a IP address and a service name, and the operating system runs off and starts a session for you if one doesn't already exist, and if one does exist, uses that. Now, you're going to go, what about different users? And the answer is different users should have different sessions. So it would actually look at your UID, and it would give you an appropriate session for your UID. So your apps would all be authenticated, but someone else's apps on the machine wouldn't get your authentication. Any other questions? In that case, please get drunk. Oh, what? Oh. Well, the reason SIP is yeah, right. The question was, SIP goes through an auto-negotiation process to find a port number when it actually connects between one person and another. Part of the reason it does this is to avoid firewalls. And this goes back to the networking monitoring question. And his question was basically what happens to network monitoring. And the answer is, well, it gets a little bit different. You won't have firewalled ports anymore if no one's using ports. So the answer to the question about, what does SIP need to do, it's straightforward. It uses the name for SIP. And it says, I want to start a SIP connection. And if there's a firewall that happens to be around that sees that, it can block it just as if it can block ports today. And in fact, from one perspective, it makes the network monitoring side easier. From the other perspective, if you enable SSL, it all goes away, and it can't see a thing. So if you enable SSL, radically easier. If you want to monitor your network, radically harder. Yeah.
So, for network monitoring with this, we're not going to be able to have monitoring on more per second as we go deeper into the packet and allow authentication information that will then define what packet is using.
You're going to be going deeper into the packet in the sense that, you'll be going through another layer. Conceptually, you'll be going deeper into the packet, but whether that actually translates into a hardware performance problem, I'm not sure I'm convinced. Yeah, you have to process it differently, but you're not necessarily processing more data. You're processing port numbers now anyways. So it's not fundamentally different. The exact construction may make it so that it's less computationally efficient. Anyways, it's about that time, so I'm going to go ahead and wrap it up, and if anyone has any questions, room 104. Thanks.